Welcome to Daily Bible Devotions. We are now on our day 4 of exploring the cosmological argument for the existence of God. And if you remember, yesterday we already ended with two scientists, one mathematician and one physicist, saying that there is no such thing as an infinite universe. Of course, it wasn't as simple as that, but their discoveries, their work, showed that there is no such thing as an infinite universe. And if their discoveries led us to that, then it means that the universe had a beginning. And if the universe had a beginning, that is actually our second premise. If you remember the cosmological argument, it goes like this. First, premise 1, everything that had a beginning had a cause, and we're able to establish that easily because of the law of causality. On number 2, second premise, the universe had a beginning. That was proven by Einstein and Al-Ghazali by their works. And now, if the universe had a beginning, let's try to understand this more. What is the beginning of the universe? And the immediate and quick answer to this is known to so many of us. It's called the Big Bang or the Big Bang Theory. What is the Big Bang? Now, for us to easily understand the Big Bang, an acronym was proposed by authors Norman Geisler and Frank Turek. That acronym is this. It's called SURGE. What does SURGE stand for? Well, it's like this. S stands for the second law of thermodynamics. Second, U is for the universe is expanding. R for radiation from the Big Bang. G for galaxy seeds or CMBR. And then E is for Einstein's theory of general relativity. Let's start first with S, the second law of thermodynamics. Now, for more information on this, I would suggest that you ask your science teacher about this. But basically, it's this. The first law of thermodynamics says that energy cannot be created nor destroyed. Energy is constant. That's the first law. Energy cannot be created nor destroyed. A simple illustration of that is that if I eat food, for example, I have a cake, okay? My cake has energy. How do we measure the energy in a cake or in any food? Simple. Calories. Calories is a measure of energy. You can even see that in the nutritional facts. Okay, cake has calories. It has energy. Once I eat the cake, the energy from the cake does not disappear. What happens to the energy is it only gets converted. So it's not destroyed, it gets converted. The energy from the cake transfers to my body. And now, if I don't work out, if I don't sweat it out, the energy will remain in my body and will become fats. So what do? I will work out. And if you work out, there are measuring devices that measures the amount of energy you're burning. You burn it. You burn the calories. You burn the energy that you absorbed in your body. So once I burn it, it will turn into heat energy, and then it will dissipate into the air and into the universe. So it's just there. It did not get destroyed after I worked out. I said I burnt it, but actually it gets transformed into heat energy and it only dissipates to the surroundings. All energy is there. It's just constant. It's just transforming from one to another. Okay, the second law of thermodynamics states that, among other things, the universe is running out of usable energy. Oh, wait, how does that happen? The first law says that energy is constant. It cannot be created nor be destroyed. But the second law states that we're running out of usable energy. What does that mean? That means the energy reduces in quality. Okay, the first law of thermodynamics talks about energy being constant in terms of quantity, the amount. Okay, and the amount is constant. If, let's say, the energy in the universe is 1,000, okay, it remains 1,000. Whether I convert it into a cake, I eat it, I work it out, it's still 1,000. The total amount of energy in the universe is still 1,000. But the quality of the energy of being usable is decreasing. It's called entropy. Now, again, if you want to know more about this, ask your science teacher. But in a sense, the second law of thermodynamics is like saying that it's decaying, it's rotting, its usability, the quality of the energy is decreasing, continuously decreasing to the point that you can't use it anymore. If it's dying, if there's entropy, then therefore there must be a beginning. So that beginning points to the Big Bang. Okay, let's go to letter U. Universe is expanding. Now, I've mentioned already yesterday about Edwin Hubble or the Hubble Space Telescope. If you look at the Hubble Space Telescope, you will see red shifts in the galaxy. That means they're moving farther away from one another. And if they're moving farther away from one another, it's like they're expanding. If they're expanding, you can just imagine if you roll the tape back, they're expanding. So that means they're coming, rewind, 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 rewind. That means they're coming from a single point way, way, way back in time. Okay, and that single point and that their expansion, this describes the Big Bang. Okay, let's go to letter R. Radiation from the Big Bang. If the universe originated from a single hot, dense matter and then it exploded, it expanded, then there must be a radiation. Arno Penzias and Robert Wilson detected strange radiation on their antenna at Bell Labs. So, in effect, the discovery of the fireball radiation or the radiation from the Big Bang burned up any hope in the steady state. So, that proves, again, the Big Bang. And then let's go to G, galaxy seeds. And these galaxy seeds, I put there the acronym CMBR. That stands for Cosmic Microwave Background Radiation. So this is the name of the radiation that was accidentally discovered by Penzias and Wilson. If the Big Bang actually occurred, scientists believe that we should see slight variations or ripples in the temperature of the cosmic background radiation that Penzias and Wilson discovered. Okay, so if there was an explosion or expansion, there must be a radiation. Then the radiation was discovered, right? So if there was a radiation, there must be slight variations or ripples in the temperature because that is what would be characterized if there was an explosion. These temperature ripples enabled matter to congregate by gravitational attraction into galaxies. So in short, these ripples from the radiations would allow for the formation of galaxies. That's why I said there, it's put there, galaxy seeds. In 1989, the search for these ripples was intensified when NASA launched the 200 million satellite called COBE, which stands for Cosmic Background Explorer, COBE. So carrying extremely sensitive instruments, COBE was able to see whether or not these ripples actually existed in the background radiation and how precise they were. When the project leader, astronomer George Smoot, announced COBE's findings in 1992, his shocking characterization was quoted in newspapers all over the world. He said, "If you're religious, it's like looking at God." A scientist said that because of what they discovered, because they saw these ripples, these galaxy seeds. If you look at the infrared pictures of the ripples, it looks like seeds. That's why it's called galaxy seeds. Not only because it led to the formation of galaxies, that's why it's called galaxy seeds, but the infrared pictures, they look like seeds as well. We have SURG, and then the final and fifth is the Einstein's theory of general relativity, which we have already discussed yesterday. So we have completed the scientific evidence for the Big Bang. And I want to show you this. This is the COBE satellite. Wait for it. There it is. It's a COBE satellite. And then this is the infrared picture of the galaxy seeds. Now, they're closer to one another, but if you will refine the image, you will see that there will be like several seeds scattered all around the universe. These photos are from NASA, by the way. We have already completed this. The universe had a beginning. That's already the second premise. If we have proven first premise, the second premise, therefore our conclusion stands. But we will talk more about our conclusion tomorrow.